Alright, so count the number of winning sequences. We are given two players, Alice and Bob, and question defines a game where we have fire, water, and earth. We have a rule where fire wins against earth, earth wins against water, water wins against fire. So that's the rule, and we are given a string. So this string basically is the turns that Alice is going to play. Alice is going to play this, and for every turn, Bob can play such that no two consecutive turns of Bob will have similar turns, right? So if Bob plays fire here, then in the next turn Bob can't play fire, right? That's only true for Bob, right? Because for Alice we are already given a sequence. So now we need to find the number of ways Bob can win this game. And during draws, we don't assign any score to either of them. We assign 0 0 to both of them. So uh, no change. And by the end, if Bob's score is greater than Alice, then Bob wins, and that's it. That's the game counted as a valid game for the answer. And suppose this is the example: fire, 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 and Alice can, sorry, Bob can play water. Now Bob can't play water, but he can play fire. Again, Bob can play fire. So Bob will try to win, obviously. Just he would be careful to not play two consecutive similar turns. So this is one way. Then the other way is fire W fire, fire water fire. The other way is W E W, and that's the only way. And these are the answers. Three will be the answer. So we basically can do a take or not take approach to it, knapsack approach, where we either we play all the turns and see what further turns we can play, and by the end we see if this sequence is going to win against Alice. If yes, then we are going to count that. That's it. So for our DT, if we do it recursively, top down, then we are going to need what states. Well, I need to know what was the turn that Bob played last. So last, uh, where we are at the index, what's the score of Bob? So Bob score. But since if we take Bob score, I'm sorry, if we take Bob score, then we need to have Alice score as well, because uh, there can be three wins, right? Three ways game can go: either draw, Bob wins, or Alice wins. So if there was only two ways, then I could have gone with just Bob's score. If I take Bob's score, then I have to take Alice's score as well. So instead of taking Bob's score, I can take a game point for Bob. So if Bob wins, I will increment game. If Bob loses, I will decrement game. And if Bob, it's a draw, then I won't touch game. So that's better, so that we can have just one state instead of two. And that's pretty much it. Let's solve this problem. Initially, since we are given F, E, and W, right, we need to set the indexes and mapping for easier access of these characters, right? So uh, so this will be character mapping, character mapping to integer. We can do it this in different ways. I'm going to take a certain approach, but this can be different. So this will be, suppose fire will be mapped to 0, uh, water will be mapped to 1 and earth will be mapped to 2. This will be 1, this will be water. And finally, one more thing, uh, we can have a rule. So instead of having if statements inside our recursive function, we can have something like a mapping to check which character wins against which character. Alright, so I copy this. So fire wins against earth, water wins against fire, earth wins against water. Alright, and we are going to have a recursive function called solve. We need to pass string, of course. The first state will be the index, the score. So it should be 0 and a character, anything, because last character can be anything initially. I want to select something that is not going to affect my answer. So S, this is not going to affect my answer. So I'm going to have the recursive function parameters will be string. Be careful because this can be this is passed with reference because it can make or break. It becomes more efficient with reference. Uh, Index, score, and character last character. If the index is already exhausted, then I can return 0 or return the status of the game, who won. That depends on score, right? If score is greater than equal to 1, then Bob won. Otherwise, I want to return 0. So if score is greater than equal to 1, return 1. Now since I am going to have a take or not take approach, right? Or here should I say Bob is going to try every possible turn that is there possible because it depends on last. So I will try to go through all the possible turns that Bob can have from the map. So Bob can have turn, win. Alright. So that's what this win is basically against this character. This wins. So if last character is not equal to the current turn, then try to solve this function with S index plus 1 score, but score depends, right? What should be the score? Let me just rearrange this so that things are better. Here I'll pass last. So what will be last? The current turn will be the next last. So this will be last. Now score. So score will be increased if Bob wins. When Bob will win? When this win is equal to the S of index, right? So if win is equal to S of index, then score plus 1. Otherwise, uh, otherwise it's a draw or a lose for Bob. Okay. When will it will be a draw? When turn is equal to the S of index, right? So when turn is equal to S of index, mm, let's leave it a bit little. Yeah, this is fine. So if turn is equal to s of index, then it's a draw. So I'll pass score as it is. Otherwise, I will decrease the score since Alice won, and that's it. So I will have an answer which will keep increasing as I complete the iteration for one particular game. So answer plus equal to, and I'm going to return answer. Let's see if this works. It won't pass because we need to minimize it. Okay, there was some mistake. Fire against earth, water against fire, earth against water. Uh, Index. Sorry, this should be arranged because this should be S0. Let's see now. Okay, it does work. We are going to have three states. For score, we need to be careful because score can be negative, right? We can have score -1 from 0, so it can go negative. How low can it go? Well, all of this game is won by Alice. Can be a case where score can be negative n, where n is the string length. So let me take the length in n, have a 3D DP. Let me call it cache. So first state can go from 0 to n. So n plus 1. Uh, so this is character, right? So this can go from 0, 1, 2, right? This is what will be 3. And finally, sorry, this will be 8. This will be 3 vector of 8. This will be 2 into n plus 1. Why? Because it can be negative, right? So we need to take into account that. And this should be initialized with -1 values. Let me take this outside and make it cache.resize. Alright, so I don't need to pass it. This is it. At this point, I'll check if the answer exists in cache, which means index uh, map index of last, because I need integer here, uh, and score plus n, because it can be negative. So if it is not equal to -1, then just copy this up and return this and initialize it here. And that's it. Let's see if this works. Okay, let's submit it. The okay, 925. So this my bad. We need to mod it as well. So let's get the mod 1e9 plus 7. Let's mod it here and let's mod it. I think that's it. Let's see now. The time complexity will depend on index and score because last is just 3 in number. So index will be going from n, varying till n, and score will be varying till n as well, linear. So this will be n square in terms of time, and space will be O of n square again because last is just constant. So that's it. That's the third problem.